Right, question 2. What we've got here is we need to define the range of f. So the way I do that is try the extreme values of x, understanding the fact that the middle values will just be ranges within that. So if x equals 1 and x equals 16, then what will fx produce? Well, fx when x is 1 will give us 63 divided by 3, so fx is 21. And 16 times 4 gives you 64, take away 1 is 63, 63 divided by 63 is going to be 1. So we've got 21 and 1 there, so the actual range is including those values there. But 1 to 21. B, the inverse of f is f to the minus 1. So if we've got f to the minus 1, what we do is we change around fx for x and any x values then for y. And then we're going to make it y equals again. What we'll do at the same time is let's just bring the x down here. Add the 1 over. And then divide by 4. So there we have then the inverse function. Part 2. Solve the equation f to the minus 1x equals 1. So what we've then got is a quarter of 63x over x plus 1 equals 1. So we times the 4 up first of all, then take the 1 over, swap the x and the 3 around, which will then give us 21 as our solution. C part 1. Function g is defined by gx equals x squared. For that, write an expression of fg of x. So fg of x is the function of x with g in it. So the function of x there, but instead of an x, we then put what g was. Part 2. Solve the equation of that equals 1 this time. So I times it up that side and add the 1 to this side at the same time, so I get 64 then equals 4x squared, divide through by 4, so x squared is 16, not 8. 16, so then x will equal plus or minus 4. Now if we then look back, this is where they sometimes get you. At this point here, why would you only take minus 4? And if you have a look why that would be, that's because you look at g of x, which is what will define your domain here, is from minus 4 to 4. Sorry, minus 4 to minus 1. So therefore, that's the only one you take. Put it across through that bit.